Hello guys, just chilling here at the college, and I thought I'd make a video. It's kind of quiet here in the building, so now I picked a nice spot on the third floor, and hopefully no one will bother me. And we're going to be doing the derivatives of the inverse trig functions, not the hyperbolics, just the regular ones. And my method that I found of doing this was implicit differentiation. So, I'm gonna put the camera right here. Hopefully it'll stay stable. And if not, then it's whatever. I'm doing this in one take. So right here we have y equals inverse sine of y, or arc sine of x, I'm sorry. So we can define this implicitly as x equals sine y. We can now differentiate both sides, or I'll say take the differential of both sides. We have the dx equals cos y dy, or you could just say 1 equals dy, cos y dy dx. Now we solve for dy dx. We have dy dx equals secant y. Now what we need to do is turn this into a form where we can get this back. So for secant, this one's a little complicated. We write this as 1 over cos y. Alright? Then we're going to want to basically use the triangle where we got this from. So this would be our angle x. We know that sine we will define it as x equals sine. So sine, our angle is y, sorry. I'm going to put this here. Now y'all can see this. So sine of y would be x over 1, opposite over adjacent. Opposite over hypotenuse. So this is sine of y. Now, solving this triangle, we get this side right here is 1 minus squared. So, it means cosine y equals 1 over square root of 1 minus, it's just the square root of 1 minus x squared. But then secant, or what we had here, or 1 over cosine, will be 1 over this. And thus, we can plug this back into here. So we now know that dy dx equals 1 over square root 1 minus x squared. So that is how we get the derivative of arc sine. So I didn't allow myself for that much room. So it's the same concept here. Just do this is cos y equals x, negative sine y equals 1, or dy dx. And we have triangle y. Now we have, this is x, this is 1, this would be a square root of 1 minus x squared right here. So now, the camera might fall, but we have, so dy dx equals negative cosec y, and cosec would be this over this, so this becomes dy dx equals negative 1 over square root of 1 minus x squared. Now if you want, because there is a more general form where you have the x over a, it's the exact same principle, you just have to factor out the a. Exact same principle. You can try that out on your own after you're more comfortable with these. So for inverse tan x, this is actually what I found to be the easiest one. So all you have to use is these identities up here for these this one. So for inverse tan, we have x equals tan y. So now we have x equals secant squared y, or 1, sorry, dy dx. Then we have, now we know secant squared is just 1 plus tan squared. So we can rewrite this as 1 equals secant, or 1 plus tan squared dy dx. Now we know tan y is x, so we can rewrite, well, we know now that dy dx, we'll do this step first, is 1 over 1 plus tan squared y. We don't even need a triangle because we already know that x is tan y, so we can replace tan squared with x squared. This equals 1 over 1 plus x squared. Simple as that. For arc sec, this one is kind of interesting. So we do x equals sec y, 1 equals secant y tangent y. This is all just from knowing your derivatives, dy dx. So now we solve for this. Dy dx equals cosecant, or it's just cosine y cotangent y. So there are a couple things we can do here. I'd say the easiest way is just using the triangle, although there are other ways. I'd say this would be definitely the easiest. So you have the triangle, and we know that sec is this over this, or this over this. So we have it, this is x, this is 1, square root of x squared minus 1. Not 1 minus x squared because the x is a hypotenuse. So we plug this back into our triangle. We have dy dx equals cosine y is 1 over this, so it would be 1 over x times. So now we have cotangent, which is this over this, adjacent over opposite. So we have 1 over square root of x squared minus 1. And that is how we get arc sec. The root of arc sec. And, arc cosec is the exact same method. So arc cotan, we're going to use this identity up here. So we have x equals cotan, and I will be doing a video later where I go through all these derivatives, every single common derivative. But these ones I just wanted to make a quick little video, just doing these. So we just do 1 equals, we take the derivative of both sides, equals cosec squared negative cosecant squared y dy dx. So now we can rewrite this as dy dx equals 1 over negative, there's no need for 1 over. You just write this as negative sine squared y. Now what is sine squared? We'll use a triangle because it's the easiest method, just the triangle. Whenever you're working with trig, there's always triangles involved. That's where they come from. Y, so cotan, y is this over this, so we have x, and we have 1. We have the square root of squared minus, or square root, or there's no square root. Well, there is, but it's x squared plus 1. So now we can evaluate this. So sine would be this over this. So dy dx equals 1 over the x times the square root x squared plus 1. That does not seem right, but you can fact check me on this one. And yeah, that's basically it for derivatives of inverse trig functions.